All right, welcome again. So today we're going to look at the division of polynomials. So when it comes to division of polynomials, there are two basic methods. The first is what we call the long division, and then the second is what they call the synthetic methods. So we're going to look at both, but for this particular session, we're going to focus on the long division. So the best way to learn these is actually just to do examples, because we know the theory behind division. So we've done long division on numbers. So it's the same principle that we're going to apply on polynomials. So we have our examples. There's example number 1, number 2, and number 3. So we're going to go through these ones quickly. So this is our first example. Now, when they give you the polynomial in this format, and they emphasize that you need to use long division, or you need to use long division, the first thing you need to do is to redo it. You just write it again, but in the format like we used to do with small numbers. Maybe you're dividing into 12 like that. Okay. So now the division of polynomials, the key term that we need to use is this term here. Okay, that's the one that divides everything through. Okay, so you don't consider this one when dividing. It's only used when you're multiplying down. Okay, I'll show you now. So this one so you divide this term into the first term here. That gives you 9x squared. So this is 9x squared. Okay. Then I'm going to multiply this. Okay. I'm going to multiply this same term, this whole term here, with that term here. So I'll get 27x3. Again, this whole term I'll multiply it with. This is the only time that this comes into play. So I'll multiply this and this whole term here with its sign. Okay. So I get 18x squared, right? So then I'm going to subtract these two terms. Okay. This and that gives me they cancel out, and then this minus and minus becomes a plus. Remember the lessons we did in the beginning. So this becomes 27x squared. Then this we're going to, because I'm dividing with two terms, so it's always very clever to just bring it down quickly here, right? So now what I'll do is I'll also get from here to there, I'll divide these two. So that will give me plus 9x. Okay. Then this term times this whole structure here, I'll get 27x squared. And then this times that gives me minus 18x, like that. Right? So again, I'll subtract here. Okay. These two terms, they cancel out, minus 3x, and then this negative and that negative, they make a plus. So I have 18x minus 3, which is 15x, like that, right? Then again, I just quickly bring this down. This comes down to here, minus 10. Remember that one came down to there, right? So I'll get this guy again and divide into here. So I'll get a positive number. Okay, 3x gives me 5 here. And then 5 times that gives me 15x. 5 times this one here gives me minus 10, like that. Now you can see that these terms are similar, so our remainder here is going to be 0. I don't need to state it here, okay, because it's 0. Now, what does it mean? This means that I've got these two factors. I can show this in two ways. I've got two factors. So my first factor was 2, 3x minus 2. My second factor is 9x squared plus 9x plus 5. Okay, this is not part of the equation. I'm just showing you this will be the structure. Okay, and that is why they will give you to say that these polynomials, like polynomial x, is going to be its factors. Okay, let's say there's d, and there's qx, and then you're going to add the remainder polynomial. This could be a number, this could be a polynomial. So like in this case, if I had 1 here, okay, that I would add it there. If I had something like x plus 1, then I would still add it here, x plus 1. Okay, but in this case, we don't have a remainder, so it's a quiet function. So you have to know, you have to write it in this, if you are indicating the whole polynomial, or if you are trying to show the new, you are trying to show the answer, then you can just, the answer of the quotient, you're just going to show that one. So that's one method we can do. So what if they gave you a function like this? How are we going to try and find the quotient here? Okay, so we still do the same thing, right? So we do it like that. Then the main polynomial is one that's going to be inside this division sign. Then we're going to have that, right? So that's our function there. So how do we start? Again, this term is the most important. We divide into here, it will give us 6x. Then into, we multiply 6x squared, and this is going to be minus 24x, like that. Then we take away this new structure here. This and that cancel, right? Then this is minus, this is plus, meaning that we're going to have a minus here, right? If we have a minus here, it'll be what? Minus what? Minus 2x, okay? Then we bring down the 12 plus 12 here, right? What's the next thing that we're going to do? We're going to divide this, right, into this term here. We're no longer interested in this one here, okay? We cannot divide x into 26, okay? We don't do that. We divide this into the new x, right? So this will be minus 2. So minus 2 times 2, it's times x, like that. Then this times that will give us plus 8, right? This whole structure, we're going to take it away. So this gives me what? This is going to give me those two cancelling out. Then here, this will be minus, and then that will be 4, right? So we said that we can express this in two ways. We get the factors. I've got a factor here, okay? I've got a factor here, and I've got a factor there, and then I've got a remainder. So I can express this whole expression as follows. So I can say it's going to be, the whole function is going to be x minus 4, like that. Then the other factor is like this, right? Then the other factor is what? It's 4 plus 4, like that. Okay, so this is how this is going to be. That is the whole polynomial. So you have your factors here, and then you have your remainder there. Okay, so if I expanded this and I gave it that, it'll actually give me this one, because this is these are the factors and that's the remainder, okay, of this whole structure here. Or you can express this in terms of the what they call the partial fractions. Okay, so what are these partial fractions going to be? You're going to have you divided this into there and it gave you this, so you're going to have 6x minus 2, like that. Okay, now you're not going to divide it with anything because that's already a solution, but what didn't divide was this part here, so you're going to have 4 over x minus 4. So when you do your integrations and differentiation and all, and you need to make partial fractions, this is what will be happening. So this will not have the division sign because we've already divided. Because if I want to expand this and that will work together. Okay, and then this will become the common. So for example, if I were to add them, okay, if I were to simplify this and that will multiply. Okay, and then this minus 4, and this into there is 1, so I'll have plus 4. Okay, and you'll notice that this now is the same as this one on top here. And that's why I was saying that you can express this in two ways, where you just express the one on top, which is this, and you can see it here, or you can express it as a partial fraction. Just depends on what you're trying to do. And this is our last example, okay, number 3. So now here, what do? This is the divisor and that's the numerator here. So what do we do? We still do the same arrangement. Doesn't matter if there are 3 or 4. The divisor comes here and then the numerator comes under here. Now, what we need to be careful with is that we saw that the highest power here is 4. Okay, the highest power is 4. Now, if it's got 4, what does it mean? It means that we're going to have 5 factors or five terms. Okay. Now, if we count here, we have 1, 2, 3, 4, which is not right. So we need to look for the factor that's missing. So we see here there's 4, there's 2. That's not right, okay? Because now we look at what? We look at this here. We see that there's going to be a 0, x, 3. Oh, you have to show all of them. Then here there's going to be plus 6x squared. We continue. Then minus 3x plus 1. Like that. So now we have 1, 2, 3, 4, 5 terms. Now again, the most important factor will be this one, or term, because that's the one we use for dividing. So here into that one gives us 4x squared. Then we multiply with all these terms here. So we have 8x4. Then this is going to be minus 4x3. Remember, we said that in our initial notes, we said that if we are multiplying, for example, these 2, it's the same as saying this is x1 plus 2. So this is going to be x plus 4. So if these are not very clear with you, please go through the initial videos that we went through. We tried to build up from the basics to this, and it will still continue to advance step by step. So if you miss out a step, sometimes it's very difficult to master. So you see, so this is going to be plus 8 x squared. So you have to be very careful with the powers, the signs. It gets easily very confusing. Okay? So I'll cancel this and that because they've got the same signs and I'm subtracting. So this becomes positive. So this becomes positive 3. Then this and that, they're subtracting. So what does it give us? It gives us minus 2x squared. Now, 4x, that becomes minus x squared. Then this becomes minus 3, because I'll just bring it down like that. Okay. Now, since I've brought this one down, what I need to do is to divide this into there. That gives me plus positive and positive. So that gives me plus 2. This has got a power of 1, meaning that that's going to give me x. Okay, so I multiply with the whole equation again. So that gives me 4, because I'm multiplying this one here with the whole term there. So I get 4x squared, right? Minus this and that gives me 2x squared. And then this and that gives me minus 4x. Actually giving me plus 4x, okay? Right, so now we're going to say we take this whole thing away, right? So this and that cancel, that and that cancel. Then this is negative, minus, positive, this becomes minus. And so we have minus 7x. Then again, we bring down the 1. Now this is a crucial point. This is 2x squared, and that's minus, this is a lesser power, so we don't divide those, we leave it there. So this becomes our remainder, okay? So I can say remainder minus 7x plus 1, like that. So what does this mean to us now? It means that we have a complete polynomial. Now, if I want to write it as a complete polynomial, I can write it like 4, right? Let me write it in different color. So I can write it at 4 because I'm looking at factors. What are our factors? It's this one here and that one there. Okay. So 4x squared plus 2x, like that. Then what's the other factor? The other factor is going to be 2x squared minus x plus 2, like that. Then what will be our remainder? Our remainder will be or plus, okay, minus 7x plus 1, like that. That will be our base polynomial. Now say that I want to express this in terms of partial fractions. So if I want to express it in terms of partial fractions, this one, I'll not show it directly. So I'll just show the factors. The factor, I got the new factor. Because after dividing, I got this factor. Okay. And then I had also a remainder, which was minus 7x plus 1 over, now this one appears. So I can say 2x squared minus x plus 2. All right. The other thing I can do is we looked at these symbols here. I can actually let this one come outside here. So I can say this now becomes 4x squared plus 2x, then minus for this whole structure. Then this one becomes positive, this one becomes minus, and this one becomes like that. Remember we did all these when we did the other division of real numbers, fractions. Remember, partial fractions, you actually meet them when you start to do your advanced concepts in mathematics like calculus and all.